Dan Abbott. I'm making this video for the SeaTime class in Marine Science at Southern Maine Community College. I'm going to talk about converting latitude and longitude angular measurements from decimal degrees to degrees, minutes, and seconds, and then using that information to plot a position on a chart. First one is one we did in class. I'm going to go through and do it again, but what we're looking at is this. That's 43 degrees. Oop, hang on. I typed that in wrong. That's 43 degrees, and then 6762 as a decimal portion of 1 degree. So right up here it tells you 1 degree is equal to 60 minutes. Let's just make it put a space there. 1 minute is equal to 60 seconds. So if 1 degree, and think of it as an hour, is equal to 60 minutes, any decimal that's more than 0.5 is going to give us a value that's more than 30. Any decimal less than 0.5 will give us a value that's less than 30. And you can estimate roughly, when you take a look at a decimal value like this, what the range of possibilities is. Engineers refer to that as estimating in advance the range of possible solutions. Now, if I look at that, it actually looks to me like about 2/3. 2/3 means the 3 goes into 60/20, 2 times that is 40. We're looking for a value close to 40, and in fact, that's what it's going to come out as. But rather than just think it's 40, we're going to go over here, and we're going to multiply 0.6762, the decimal value, times 60 to find how many minutes are represented by that decimal value for a degree. And in fact, it is 40. So we put the 40 right here. However, it's also got a decimal value for it as well, and these are minutes. So if I just subtract the 40 and you get only the decimal portion, looks like that. That's a little more than half. Well, there are 60 seconds in a minute, so we should be looking at something a little more than 30 seconds. Multiply this times 60, and we get 30. Oh, sorry. Do that one more time. We started off with 0.6762. We multiplied that times 60 minutes per degree. We subtracted the 40 after writing it down, ended up with 0.572, multiply that times 60, and we get 34 seconds, and then a decimal value as well. If the point for the decimal point, if the value after the decimal point is 5 or more, we're going to round that up to 35. If it's less than 5, we're going to round that down to 34 because you need a whole number for the seconds. So we're going to say 34. So you'd write that 43 degrees, 40 minutes, 34 seconds north. There's no positive sign here, but you notice there is a negative sign here on longitude. That negative simply means we're west of the prime meridian, which is the line that goes down through Greenwich, England. The fact that it doesn't have a negative means we're north of the equator. But if you put the N in here, or the W over here, which I didn't put in yet, put that in now. Put the W over here, you don't need that negative. That negative is just direction. Now let's do the calculation on this one. Come over here and say, all right, 70.2411, that's about a quarter of a degree. Quarter of 60 is about 15, so we should be getting a number close to 15. We come over here and we type in, let's clear that first. We come over here and we type in 0.2411. We multiply that times 60 minutes per degree, 14.46. We're going to write down the 14. That's how many minutes there are. But it goes beyond the 14 by 0.466. And we can see that again. That's a little less than half, so we should get a number a little smaller than 30. The number I got here was 28. And the reason is that if I subtract the 14, I'm left with that decimal value of a minute times 60 seconds per minute gives us 27.96, rounded up to 28 seconds, so it's 70 degrees, 40 minutes, 28 seconds west. I'm going to do one more now, starting from scratch. We come down here at 6133. Clear this, 0.6133 times 60 minutes per degree, going to be something more than 30. 36, so we're going to write over here, we're going to write that in as 43 degrees, 36 minutes, and now we have a fraction of a minute, which is about 3/4, which would be about 45 seconds. So we subtract the 36 over here, equals that value, times 60 seconds per minute, and it comes out pretty close. 47.88, we're going to round that up to 48, come back over here, that now becomes 48 seconds, and we're going to write that as 43 degrees, 36 minutes, 48 seconds north. Do the one over here, we start the same way, 1967, 0.1967. We clear that, 0.1967. And again, we can estimate that. It's about 0.2. 0.2 times 60 is going to be about 12 minutes. So we multiply that times 60. And we get a value that's close to 12, but it's not 12. So we're going to write down 11 over here. So we come back over here. 70 degrees, 11 minutes. And now we have to figure out how many seconds. 0.8. Well, you know it's going to be up close to 60, so 8 times 6, figure out what that is, it's 48, so we're looking for something like 48 seconds. Subtract the 11, equals 0.802 times 60 seconds per minute equals 48. Come back over here, we're typing the 48 because the number after the decimal point is less than 5, so that's seconds and that's west. So that's how these are solved. Now we're going to plot both of these on the chart. So I'll make this bigger now. So we're going to do this. We'll do the latitude first. The latitude scale is on the vertical scale on the left and the same scale is on the right. If you take a look at it, everything, all the latitudes that we're going to be dealing with in this class, since we're in Casco Bay, all of them are going to be based on 43 degrees. So if you come right there, it shows you 43 degrees. Now just give this a second, the resolution will get better. So 43 degrees. Everything is going to be 43 degrees because where we are in Maine, there is no place we're going to get in Casco Bay that is north or south of 43 degrees. So there's your degree symbol, that's 43. Now the question is, how many minutes do we have? So the minutes are given in these smaller numbers. If you kind of come up the chart, you get 35 and 34. The distance from that line right there at 34 minutes up here to 35 minutes, that distance right there is 1 nautical mile. I'm going to show it to you right up here. 1 nautical mile. So you can measure distances on the latitude chart. You cannot measure them on longitude. Longitude is about 70% of an actual mile when you look at 1 minute of longitude. That's because the latitude lines are evenly spaced. The longitude lines are not. They get closer and closer together as you get closer to the poles. If we were right at the equator, the longitude and the latitude would both give you nautical miles per minute as 1 nautical mile per minute. Now when you need to do something where the increments are a little bit smaller, there's always a portion of the scale right on the middle of the chart where you notice here it goes from 40 minutes to 41 minutes, and then it divides individually, it divides these things up into seconds, 10 seconds, 20, 30, 40, 50 seconds. And just to be allowed, just so you can measure in individual seconds, down here there's a 1 10-second increment from 50 seconds to 60 seconds, and each of those is broken up, or this is broken up into 10 sections. So 51 seconds, 2, 3, 4, 5 seconds, 56, 57, 58, 59, 60, that's a full minute. You don't write the 60, you write the minutes instead. That's the scale you're going to use to measure as small as 1 second. Now, if we take a look over here, we're looking for 43 degrees, 40 minutes, 34 seconds. What we need to do is find that on the chart. Let's do it over here. Notice on this side, you've also got same thing. So we're looking for 40 minutes, which is right here, and beyond 40 minutes, 34 seconds. this is kind of handy that it happens to be right here. From the 40 up to here is 30, so we need to go beyond there by how much? 4 seconds. So there's 40 minutes and 10 seconds, 20 seconds, 30 seconds, plus we need another 4 seconds. That 4 seconds can be found right down here. How do we transfer it? You're going to transfer it by using a set of dividers, or you could use a little piece of paper, or you could measure with anything. I'm going to use a set of dividers though, just to show you how to use them. I'm coming over here with my set of dividers. I'm going to take and line the dividers up so they line right up with that line right there. Now what I'm going to do is to move the dividers so that this point right here goes to 40, goes to the 30. I'm looking at it right there. Now I'm going to take this other set of dividers, so that's on the 30. I'm going to move this till it comes right to 1, 2, 3, 4. Now that set of dividers is opened up to 10, 20, 30, 1, 2, 3, 4 seconds. 34 seconds is what we need to go past the 43. So we come down here. Now that we set the dividers, you're going to move that point from here to the 40, because now you know exactly how far past the 40 that point's going to be. Now what you're going to do next is you're going to make a line that is parallel to these horizontal lines, and you're going to make them from here all the way across to there. So I've done mine now in red. It's red and dashed just so you can see it. If you look over here, it's parallel all the way through. Somewhere on this line is station 00. Now where on that line is it? Well, we now have to go plot the longitude, which is the vertical line. For that we'll go to the top on that one, because when we did it in class we went to the bottom. So 70 degrees, 14 minutes, 28 seconds. So we have to go and find that location on the scale on the top or the bottom, and then project a line that comes down through that is vertical. So I've just put the longitude up here. I'm going to take my set of dividers again. I'm just going to move it up here. Now when I move the dividers up here, what I'm looking for with these dividers is the location of 70 degrees. Now 70 degrees is also all of Portland Harbor. But if you go east, if you go down east from Portland, you can get to the point where you get 69 degrees, because this is 70 degrees and then not too many minutes beyond that. But for what we're going to do on this chart is everything 70 degrees. So everything down here is 70 degrees. So now what we have to do is go and find 14 minutes. 14 minutes is right there. But how far past the 14 minutes does it go? 28, which means we're going to look for something about halfway between the 14 and the 15. So how do we actually lay that out? Well, here's where the dividers come in again. Take my dividers. I'm going to bring them down, and this time I'm going to line them up so that they line right up on that. Now, we're going to move one point. I'm going to set this. I'm going to bring it over here. I'm going to take this, and I'm going to put that leg right there. I'm going to put it on 8. So this is now 8 seconds right there, and it's beyond the 12. So I'm going to put it on the 8-second mark, which is right here. Now I'm going to take this and I'm going to move it to the 20-second mark, which is right here. Now if that's 20 seconds, the distance, the spacing on the dividers is 10 seconds, 20 seconds, plus 8, 28 seconds. Now all I have to do is move my dividers so that this point right here sits right on the 14 and goes beyond it by 28 seconds. So the dividers show me exactly where beyond it by 28 seconds would be, and you can see it is close to halfway, so that makes a lot of sense. Again, we're going to have to draw a line that goes straight down vertically, right like that, and goes straight down vertically parallel to one of these lines. And one of the things you can do to make a parallel line, you put your dividers so that it's spaced a certain distance away from this. You can make a little mark there, put your straight edge down, Then you can take this, move my dividers down so it gives me the same spacing. Because if I put it on the line going up and down, over here, it's going to be exactly the same distance away if the lines are going to be parallel. So now we have a line drawn down through here that is parallel to all the other vertical lines, and where they cross, which is right here, where they cross is going to be station 0. We'll put that right here. In fact, let me mark that with. Alright, so I'm going to bring in a little block in here. Click OK. Now I have station 0. Station 0 is sitting right here, and that will give me the first station. So that's station 0. Now, just so there's no confusion, I'm going to erase the lines I've already put in. I'm just going to delete them so there's no confusion about what it is that I'm doing. Now let's go do, down here, let's go put in station 5. So we're going to start with 43 degrees, 36 minutes, 48 seconds. I'll go ahead and copy that. And let's put it 43 degrees, 36. So we're looking for 36 minutes. There's 39. There's 38. There's 37. There's 36. So I'm just going to put this down here just so I don't forget what it is. So we're looking for 43 degrees, 36 minutes, 48 seconds. So there's the 36. We need to go beyond by about 50 seconds. That means we're going to be right in this area right here. How can we tell how far beyond it is? Actually, you got two choices here. We can find our dividers and set them equal to 48 seconds. Put one leg on the 36 and then mark up here where that 48 seconds is. Or, since 60 minus 48 is 12, we know we're 12 seconds away from the 37, so we could set the dividers equal to 12 seconds. Either way, what we're going to have to do is go find the part of the scale right here that measures in individual seconds. So what are we looking for? 48. 48 seconds can go from that 40 right there, 8 things down, or if we wanted to do 12, we could start it from here and go to 12. So let's bring in another set of dividers. Here we go. So we're going to put the dividers, in this case, let's put the dividers right here in place. Now, I can open these dividers up and close them by doing this. So what I'm going to do here is I'm going to move my divider so that this leg right there is on the 8. Now I'm going to move this leg so it's on the 40. 40 is right there. It'll look pretty good in a second. So that's 40 seconds, so it's 10, 20, 30, 40, plus an additional 8, so that's 48 seconds. Now to find that location on the latitude scale, I can move this down. I'm going to move it down until it lines up with, just make sure we understand what we're doing. I'm going to move it down so it lines up with a 36, because I want to go beyond the 36 by 48 seconds. So where's my 36? Almost there, almost there. Here we go. So I'm going to move this so that that point right there lines right up with a 36. Now that that lines up with a 36, I'm going to move this right here so that that point right there lines up with this 36. That now is where my latitude line is. So I have to draw a line that goes from here and is parallel to all my horizontal lines and goes across the chart like that. I just drew a line that goes continuously across the chart. And you notice if I were to take this, move it up to where I just put that line, which is right here, and then close my dividers until they got right down here to that, and say, well, how far beyond, how close to 37 minutes do we get? If I then move the dividers and go up and then measure from the dividers how many seconds that is, if I come in here and I put it right there, that's going to be 12 seconds, because obviously 12 seconds plus 48 seconds equals 60 seconds. So that's going to give me the latitude line. Latitude line is down here. So it's down here someplace. It goes across like that. Longitude. Now normally what you do is you go as close as possible for the scale. So we're not going to go to the top this time because that line's all the way down here. So we're going to use the bottom longitude scale. And again, I'm going to copy that. And the reason I want to copy it is so I don't forget it. 70 degrees, 11 minutes, 48 seconds. So we'll come down here, paste that in place. And since we're looking for 11 minutes 48 seconds, we get right near the 11, which is right here. So what we need to do in this case now is find something that goes beyond 11 by 48 seconds. So we'll go grab another set of compasses. We got all kinds of compasses, dividers. Do another set of dividers. Now what I'm going to do with this set of dividers is line it up. Let me put that on a different layer. I'm going to take the dividers, I'm going to line those up. I'm going to have to rotate them 90 degrees. I can do that like this. Pick this, say go 90. Now we can, where are we at? Oh, 11:48. So what we're looking for here, we see where the 11 is. We want to go beyond the 11 by 48 seconds. The scale for doing that's right over here. So what we have to do is find 48 seconds there. There's a 40. So if we put our divider tip here, and then on the 8, that'll give us the 48. So we're going to move this. And we're going to move it over here. We're going to find the 40. Put it right on the 40 like that. Then we're going to open this up, or in this case close it up, until that other point on the dividers lands right on the 8 right there. So now your dividers go from 40, 10, 20, 30, 40, 8. That's 48 seconds. We know we need to go 48 seconds beyond the 11. So now all you have to do is move our dividers from that point right there. Put them over on the 11, as close as you can come. That's where the longitude line is going to come. Draw a line that goes parallel to all the other vertical lines going up. And now where those two cross right there, that is going to be our, right here, that's going to be our station number 5. I'm going to put that in, make it 5, okay. Now it looks like that. So that's the location where you want station number 5. So you've got 0 up here, 1, 2, 3, and 4 someplace else, and they're around here someplace. That's how you're going to get number 5. So that's how you're going to place something on the chart based on knowing in advance what the location is. Now how would we go the other way? What are the other questions here? Yeah, okay, you're going to do a bunch of stuff here. So, but the question is, what if we have to go the other way? We want to know what the location of something is. One of the questions on this sheet is, what are the lat long of Spring Point Light? Well, what we're going to do is first is find Spring Point Light, draw a line that is horizontal off Spring Point Light, then draw one that's vertical off Spring Point Light. Then all you have to do is go over here to get the latitude. Come over here and you can see it's 43 degrees because everything is 39 minutes. It's going to clear up in a minute. 39 minutes. And now, how far beyond 39 minutes is it? Well, we're going to have to use our scale up here again to come up with a number, how far beyond 39 it is. And once again, I'm going to go ahead and get a divider. Bring my dividers over. Divider comes in like this. So if we put the divider, so that point right there is right at the 39, as close as we can get. I'm going to move this from here to here, as close as we can get it. Like that. And then we're going to take and close the dividers until they mark the location of that line right there. So now that is the distance beyond the 39. Now you can move the dividers. They go from here, come up here, say how many seconds is that? And this one is going to be right there. Now you're in between seconds. We always do whole seconds. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm sorry, 8. Well, yeah, I'm sorry. 5, 6, 7, 8, because it's closer to the 8 than it is to the 7. So what is that location? 43 degrees, 39 minutes, 8 seconds. 43 degrees, 39 minutes, 08 seconds. You always put the 0 in there, so everything is two decimal places. When you have the longitude, it's actually should be 3 decimal places. In fact, did I do that correctly? No. The way that really should be written right here, there should be a 0 in front of the 7. Just like that. And that's because it's possible for that number to be greater than 3 decimal places. So just to make it clear that we're talking about a number smaller than 100, and we're going to put that 0 in here like that. So that's the longitude. I'm sorry, that's the latitude of Spring Point Light. The longitude we're going to do the same way. Going to come down here, say, all right, we know that it's 70 degrees, 13 minutes, and pretty close to halfway in between. Once again, we'll go and get a set of dividers. Take that set of dividers, bring it over here. We're going to make it so that it lines up as close as possible. So we'll move this over to here. And then say, how far beyond 13 does it go? Make your dividers a little smaller. Put it right there. Now that's the distance beyond 13 minutes that it goes. Now we just have to move this. So it goes from here. You have to move it over here until it lines up with something. And you can see I'm just going to line it up here because we know it's 20 seconds. If I do that, 26 seconds. So how far beyond 13 minutes is this? It's 26 seconds beyond the 13. 13 minutes is right here. That's going to be written as 070 degrees, 13 minutes, 28 seconds west. So that's how you find a lat long from an existing position. Now the other two things you need to do is to determine bearing, and you need to determine distance. So I'm just gonna arbitrarily pick a couple of, we'll pick one of the buoys that's over near station 0. So we're gonna take that lighted buoy, and when you're laying out track lines, find a lighted buoy if you possibly can. You can't always do that, but try. So I'm gonna say, let's draw a line that goes from here, and I wanna go from here directly to, well, Cow Island Ledge has rocks near it, so we could go there, but I'd rather go, say, to that red and green right there. I'm going to go right here, enter. So there is my track line. And let me just put that on another layer so that it looks just a little bit better. Alright, so there's my track line. In other words, I'm here, I want to go there. That's what I want my boat to do. And I mentioned that a course line and a track line can be the same thing if there's no set and drift. In this particular case, we're going to assume there's no set and drift. So what I need to know in order to go and get underway is what direction I'm going, both true and magnetic. In order to do that, once you draw your line, you have to compare it to a compass rose. Now there's a compass rose over here. You'll be glad to know, folks, that I actually did update my chart this time, which I'd forgotten to do before. That's 15 degrees, 15 seconds. So we're going to have a variation of 15 degrees west. That means the magnetic heading is going to be 15 degrees larger than the true heading. And that's going to be something you can always figure out simply by looking at a compass rose and saying, well, right now, if you take a look, 0 degrees true is that way. You come down here, magnetic, it's a 15 degree difference because you swing from here all the way over to the 15 and it points that right through here. So you've got a number that's 015 and a number that's 15 degrees more for magnetic than it is for true. But how do you get that line over there? Well, that can be a little bit tricky. You've got several different tools you can use for that, including parallels, which we don't have, but I showed you mine. You got rolling rulers that work pretty well. You can kind of eyeball it. But one of the things you can always do here is take your dividers and find the center of one of those compass roses that just goes straight down. In this particular case, in order to do that, I need to extend that line. I'm going to extend my line and just make it longer than it was. I'm just going to say, let's just go straight down here like that. So you can see I drew the line now, so it goes further down. And I did that. I need to go even a little bit further than that. Now I do have a lot of black right here. So let's do this. Let's put that back on a layer that's red. And just to make it look a little bit better, I'm going to make a change to the line type of that. Make it continuous. Now I got that red line coming down through. Now the reason I did this is because if I want to draw a line that's parallel to this one, what I can do first is move my parallel, move my straight edge. Leave that line where it is, but move my straight edge so it goes right down through the center of this. And then measure the distance using the dividers from that line to the center of that. So I go back in and I pick my dividers. I'm going to bring in my set of dividers again. I'm going to take one of them and I'm going to put it right on the center of the compass rose, right here, because I want to draw a line that goes through that. Now what I need to do is to rotate this. I'm going to rotate it so that it lines up, and is lined up so that it would be about, hang on, rotate it right there. So I'm going to rotate it so it looks like it'd be about 90 degrees to a line drawn from this one down. Then I'm going to open it up until it touches the line that I just drew, that line right there. So what I'm doing, and this, right now I'm just kind of eyeballing it, but that's actually going to be close enough. I know what that distance is from here to here. I know I want my line to go through this. Now if I just move my compass to another location on that line without changing its setting, I do this, I know I'm going to need to draw a line that goes through the center of the compass rose, and then it's going to go right up here through that point right there. And if you take a look at those two lines are very close to being parallel. So that's one way to get a parallel line when you don't have a set of parallels or a rolling ruler. Come down here again. Now we're going to read the direction. 0, 6, and now you have to look at these little marks. On the inside, you have to note that that's 60, that's 90 magnetic. So in between, you've got a longer line here, so that's 60, 70, 80, 90. So each of those little marks, 1, 2, 3, 4, 5, each of those represents 2 degrees. 62, 4, 6, 8, 70. So this is reading a little more than 62. We're going to call that 62. Now you look out here on the outer rim of the compass rose. This is reading true. The one inside is reading magnetic. We have 30, but again, check and see what each of these marks must mean. If that's 60, 30, 40, 50. So it's 40 degrees to here. But now from 40 to 50, there are enough little marks, 10, to go from 41, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be 0, 4, 7. This will be 0, 6, 2. And the difference between them is 15 degrees. Now there's a slight variation here because of that 15 minutes. But we're not going to take that into account when we're putting the bearing down. We don't use anything smaller than whole degrees when we're running a course, because you just simply can't hold anything smaller than 1 degree. In fact, you can't really even hold 1 degree on a compass very well. So now once I know what my heading is, and again, because I would be doing this, by the way, not on the boat, but I'd be doing it at home in advance, because those track lines aren't going to change. We want to go from buoy to buoy, then we draw that line and do it. I'm going to call it a course line, because unless there's some set and drift, if everything goes perfectly, it will be, in fact, the heading of the boat as well. And if you don't know anything about set and drift, you don't know how you're getting pushed around, then you're going to run, your first course line will be run as though the track line and the course line were the same. So dead reckoning will take into account things like set and drift once you're underway. However, we're not going to be dealing with that in this class. Maybe sometime we will down the road. So now that I know 0, 6, 2 as my magnetic heading, 047 as my true heading. Now I can come back up here and put that above the line. So I've done this already, and I will show you in a second where I got that distance. So the distance goes below. The letter D stands for distance, 2.6. You don't go to any beyond the 1 decimal place. And if you recall, 0.1 miles, if you're going 6 knots, is what takes 1 minute to do. If you're going 12 knots, it takes 30 seconds to do. So 6 knots, 12 knots, those are really helpful when you're using speed. If you can do it, and you almost always can, because it's much easier to do the math. You're going to write this as C stands for course, 047, because it's possible if I have 3 digits here, and you want to clarify that it's 47 and not some other number. So 047, I put a T in to indicate true. Classical navigation, you don't put a T if it's not specified, then it is true, but I like to make sure that I don't make a mistake when I read it later on. And after that, 062 magnetic, so there's my magnetic heading, and this is the heading from left to right. So 0 degrees is straight up, but I also like putting the magnetic reciprocal, so if I do go someplace and I get to a location and have to turn around and come back, I also still have the course line that I'd run coming back as well. So 062 plus 180 is 242, and I put an R just to indicate that is the reciprocal. Now, just to show you when I would do this and how I would do it, let's take a look at the Casco. This is my Casco Bay chart. All those lines you're looking at right there, those lines are all track lines that I put in advance so that if I go to any of these locations, I don't have to draw anything else in my chart. So if you go down and take a look, every one of these lines, and this, by the way, is Halfway Rock. Halfway Rock is 8 miles out. It's a great nav aid because it's a red flashing every 5 seconds lighthouse. It's pretty high off the, it's 28 some feet off the, it'll tell me here in just a minute, 76 feet high. So it's very visible from almost, well, virtually from anywhere in Casco Bay. So it's a really handy landmark. So I just use that as a way of laying out a lot of track lines. So all those lines you see are track lines, including going all the way up the New Meadows River. In each case, I have a course heading true, I have a magnetic heading based on the course heading, and then I have the reciprocal as well. So this is what I would do, what I did do at home during the winter, so that when I'm underway, I take this chart with me, and if I need to know any of those things, I don't have to draw them again. I can just take that chart out. So the last thing you need to know how to do is to determine the distance between the 2 points that you are going between. That distance is important because what you're going to do if it's foggy, and that's really a lot of what this is about, you suddenly have fog, that distance is important because if you know what speed you're going, you know how long it should take to get from one buoy to the next. You keep track of your time. In this case, if we were going 6 knots and it's 2.6 miles, that would take us 26 minutes. So you time it for 26 minutes, and in 26 minutes you look around, and if you're not at the buoy you thought you were at, you're going to have to go find it, or make sure it's actually still there by looking at a current chart. So this is a critical thing when you're dealing with fog because you don't see these buoys very far away. So how did I know that was 2.6? Well, I'm using a piece of software here that you don't have, which is a computer-aided design program. And then I print my charts out periodically when the underlying chart changes. But in order for you to do this on a paper chart, what you're going to have to do is take a compass. I'm sorry, I keep calling it a compass. It's really a set of dividers. It's a compass if you put a piece of lead in one side. So I'm going to take my dividers, and if I put one point right here, actually before I even do that, let me line them up a little bit better. So I'm going to line these up so that they're 90 degrees to the line, just like that. So one point on your compass goes on one end of the line. The other point on your compass goes on the other end of the line if you can open it far enough to do that. If you can't open it far enough to do that, and that sometimes is a possibility of a very long line, if I have enough room, I can just go and put it here. And now that set of dividers measures the entire length, and then I can move over to the side and determine how long it is. If your dividers aren't long enough, though, There's another technique, and I'll show you that in a second. So right now, this is set, so it's the length of the line that we have. I come over here, and I lay this out on the left-hand side. Now what I'm going to do is move it. I'm going to move it till I find a location where it's going to give me some help in determining how far it goes. So I'm going to just put it on the 38. Now this has nothing to do with location at this point. This is simply a distance, because we know that 1 minute of latitude represents 1 nautical mile. So if I put the leg on one of those and goes 38, 39, 40, I know that I've got 2 minutes of latitude. That means I know I've got 2 nautical miles. Now the question is, how far beyond the 40 did I go with the compass? And you can see it's up here. You could kind of even estimate that. You could say, well, it's about 37 minutes. But you can get an exact measurement by just adjusting your, and I keep calling it a compass, adjusting your dividers. So to do that, you leave one point right where you found it, right where it is, right here. You take the other point and you close up your dividers so that you now eliminate the 2 mile part. By doing that, your dividers are now set for the amount past 2 miles. So if you're trying to figure out how many minutes it is past, you have a way of doing it as long as your dividers are over here where you have this smaller scale. Because if I now move my dividers so that that point lines right up with the 30, and then I start counting 10, 20, 30, 1, 2, 3, 4, 5, 6, 7, 8. I've got 38 seconds more than 2 minutes. I bring up my calculator. I take 38. I divide 38 by 60. It's going to tell me that I have 0.6 and then a bunch of 3's. Now we're going to round that up down to a single decimal place. So we have 2 miles, because we found that on the chart already, plus 0.6 miles. 2 plus 0.6 is 2.6. Now it's a little bit longer than that, but again, you don't do anything that is a finer increment or a smaller increment than 0.1. So what would happen if your dividers just don't open up long enough or wide enough to do the entire length of a line that you've laid out? So let's just say our dividers are like that. They just won't open long enough. Well, if you take a set of dividers and you move 1 point so it sits right on a minute mark, just like that, and you're going to, in fact, let's do this one. So I'm going to move that so it fits right on a minute mark. And if I put 1 point on 1 minute mark, and then I open it up so the other point is on another minute mark, then you've set your dividers to represent 1 nautical mile. So here's my divider. 1 point's on the 41, 1 point's on the 40. So that now measures 1 nautical mile. Now if I take it and I put it on my line and I measure where 1 mile is, again I'm going to move it now so that 1 point is here. Now once you've done that, what you can do is just leave that point on the line, pivot the entire divider around so this point is now on the other side of it. A little hard to visualize that with this, but basically what we're doing is saying once you know where that location is, you can leave that there, swing the dividers around so the other leg hits the line someplace else, and that will measure 1 mile at a time. So it's easier to show this by hand, but if I were to move this and say move this from that point to where, move the dividers from that point to where the other point was, which was right here. Now the difference between that, you have 1 mile, you have 2 miles, the difference between this, you can do the same thing, swing that around, and when you get done swinging that around, you just adjust the compass so that it closes up till it reaches that. So now you've got a setting. You know you have 2 nautical miles, so the question now is how much does that represent? Now you move the compass again I'm sorry, the dividers again. You move the dividers again, go over here to the side and figure out, we'll have that come in here like that. Bring it over here to the side to find out how much does that setting represent. So we're going to move this again. Now we take one of the points. We're going to move it and line it up with whatever minutes leaves the other point in right there. So we're going to move it right to here. So that's 30. 1, 2, 3, 4, 5, 6, 7. Maybe I have a slight error when I did it. 37, and then you go and do the math again, where you take 37 divided by 60, and then you're going to get a value. Well, yeah, that is what we had before. So then it's 0.6. So that's another way that you can use dividers when the line is just too long. Maybe I'll do a little quick demo by hand on this. So I just I set up the same thing. I cut up an old chart. This is a chart that I used to use before I started laying them out in AutoCAD. And this is the situation. You've got a set of dividers. There's my set of dividers. I've got a line that goes from this buoy to that buoy. Same line. I got my scale right here. And I take my dividers, and I don't have enough of a divider to open up all the way. So what am I going to do with this? I'm going to come over here on the left. I'm going to set this, doesn't have to be 1 nautical mile, it could be 2 nautical miles. I'm going to put it here and open it up till it's set to 1 nautical mile, 1 minute. Let me see if I can focus that just a little better. There you go. So if I take my dividers and I open it up, so one point is on 1 minute and the other point is on another minute, so it looks like that. Now the dividers are measuring 1 nautical mile. If I put one point on one end of the line, just like this, let's see if that's going to be visible to you. It is. Now I put the other point on the line, that's 1 mile. That's 2 miles. 2 miles plus. Now that I know it's 2 miles, I'm just going to squeeze the divider up so it goes to this end of the line. So now the dividers are set to the difference between the length of the line and 2 miles. So I know the overall length is 2 nautical miles plus. So now I bring my dividers over and I set the dividers up on the 30, and then I come down here and count, and it'll measure 30, 1, 2, 3, 4, 5, 6, 7, just like it did on the computer. 7 means 30 plus 7, or 37. Do the math, that's 0.6. So I can use a divider, even if it's not wide enough to go on the entire length. I can use that to measure the same distance, and I still get 2.6. The other thing I could do, as opposed to using dividers, is I could take an old chart and I could cut this out and cut it out so I make a little paper scale for myself. So I'll cut it out like this, cut right along that line so all the little marks show. And if I don't feel like cutting up a chart because it offends me or I don't have one, what I can do then instead is just take a piece of paper, put it down and mark the piece of paper itself. Now if you want to measure something, you can come over to that same line we just had, and I can put the 41 here, the 40 there, put a little mark, slide my scale down, so there's 1 mile, there's 2 miles. Now slide it down to that mark, and then find whatever that is, 30, that then goes where the other end of the line is in this smaller scale right here. Count them all off, and I'm going to be right here, which is 1, 2, 3, 4, 5, 6, 7. So you get the same result. So you don't even need a set of dividers. You actually just need a little piece of paper, and you can do virtually everything. You can use that little piece of paper for everything. If you happen to have an old chart, you can print that out. You can also draw something up and print it out, but really just take a little slip of paper and mark it off. So if I just went here and took a straight edge probably, but I'd be able to say, well, I got one little mark here, one little mark here. Then I could do each of the little marks inside just by lining it up. And then do each of the other ones. And now you've got your own little paper scale, and you don't even need to cut up a chart to do it.